Little video is to help you review some information that hopefully will help you do better on the Albert question. There are 5 multiple choice questions they have to answer today. So most of the Albert questions have to deal with Newton's third law of motion. Let's do a quick review of Newton's third law of motion. It basically states that for every force there is an equal and opposite reaction force. Now what does that mean? For example, let's say this is the Earth and we have an object that's falling to the Earth. The reason it falls to the Earth is because there's a force of gravity on that object. The thing that applies the force of gravity to that object is the Earth. So this is the force of the Earth on the object. This is the Earth, this is the entity that's applying the force, and this is the entity the force is being applied to. This is the force of the Earth on the object. The reaction force is the force of the object on the Earth, force of object on the Earth. So this object is applying a force to the Earth. These forces are the same magnitude in opposite direction. Or we can think of this way. This is a block of wood that's resting on the table, right? The wood is applying a force to the table, and the table is applying an equal and opposite reaction force to the wood. Let's draw that. This is the table. This is the table. This is the block of wood. This wood is applying a force to the table. This is the force of the wood on the table, right? The reaction force is the force of the table on the wood. This reaction force, we usually call this the normal force, but is the reaction force of the force of the wood on the table. This is the force of the table on the wood. Now there's also a force of gravity on this piece of wood. This is the force of gravity. This is the force of gravity. We're going to write it this way, because this right here, this object falling to the Earth, this is the force of the Earth on the object. This is also what we call the force of gravity. This writing a slightly different way. So this force of gravity is the force of the Earth on the wood. The reaction force then, same magnitude, this has to be the force of the wood on the Earth. So in Newton's third law of motion, a very significant thing. For every force, there's an equal and opposite reaction force, but you must remember that action, reaction pairs of forces never exist on the same object. They always have to be different objects. And if you remember these subscripts, this is the force of the Earth on the object, the reaction force is the force of the object on the Earth. You just swap those around, and that will help you. Now, Newton's second law of motion, you should all know Newton's second law of motion. Net force equals mass times acceleration. Remember, the acceleration in the net force, that's net force must be in the same direction. So for example, we have a velocity time graph. This is a velocity time graph. Let's say, for example, this is the velocity, constant velocity. Remember, the slope of a velocity time graph is the acceleration. Well, this graph, this velocity, this is a horizontal line. It has no slope. So in this case, the acceleration is 0 meters per second squared, which means the net force is 0 Newton. If there's no acceleration, there's no net force. Now, let's put the velocity this way, like this. This line is the velocity changing from 0 to some positive velocity. So that means we have a positive slope. The slope is positive, that means the acceleration is positive. So this line, the acceleration is positive. We don't know the value because we don't have the numbers in here, which means the net force must be positive also. The acceleration and net force are always in the same direction. Now if we have a line like this slope is negative. for this line, I'm going to put down here, this slope is negative, which means the acceleration is negative, which means the net force must be in the negative direction. Remember, the slope of velocity time graph tells us acceleration, and the acceleration is always in the same direction as the net force, or the net force in the same direction as the acceleration. Hopes this helps you get some better scores on those multiple choice questions.